Q. Well, welcome to the class. On the call, it's Tuesday morning, or nearly lunchtime, I guess. First things first, as it stands, I think I'm substitute for Marius for upcoming these 2 weeks. But more importantly, I think that's probably more on your hearts, assignment deadlines, right? So some of you, in any case, participate in a survey or a poll with respect to should we extend the deadline or not, and I think the majority, it felt at least that the majority is in favor of that. So that's why the deadline has been extended to 6th of March. That's something that works for people. 1 more week, right? So ours would be this week, now next week. And that also works for me quite well, because then we have more time to getting up the system. But that's a different story. So no, we have one version running. We want to just get the latest version up, because we have some developments, hopefully, to alleviate some of the concerns. So it gives a bit more time to play around with this. So just to ensure that everyone is on board, 6th of March, so you kind of have a bit more time to do that. I understand you have all the basics to do your assignment, right? So it's a matter of doing your assignment mostly, so it's good. And as usual, I'm coming in to spread in a bit of theory and a bit of other concepts that are relevant. And it's to some extent a cross-cutting concern with respect to the other course that you have had, Cloud, for example, but more generally as a competent application/game developer, you want to think about data transmission as one issue. And we had this as a discussion point earlier this or at the end of last year, but never really got around talking about it. So I want to make it a topic for today, and that is talking about encoding/serialization and transmission formats for data that you have all been using. At least one format you all have been using and exposed to extensively, which is
data transmission.
Yeah.
The observers.
No, not so much as that's for me. I mean, like, what data format would you use to transmit data over a network, for example?
JSON.
There you go. Good. So next time I'll try it better, so we're on rhythm, so it's good. Anyway, doesn't matter. So I want to make this a topic for today, because part of the reason that's important to talk about it is, well, guess what? There's more than one format. So, and sometimes, or for you, it's important to have kind of a bit of an overview and understanding what kind of formats are there, what are the trade-offs, why are we using this one, why not another one, right? And, you know, when should we at least consider using other formats, right? And this is in part grown out of a discussion that we had on the issue checker last year in Cloud, where it was really about, hey, isn't XML something from the Stone Age? Why do we still do this, and why do we need to learn about this and stuff, right? So and it felt more so why don't we use XML? Anyone?
Size.
Okay, yeah, good. Anyone?
JSON is better.
Sorry?
JSON is better.
Yeah, that's the thing. That's the problem with the university. We don't just say better, we say why it's better, right? So that's the thing, because that's what we know now, right? So basically say, yeah, go for JSONs, you know, it's faster and it's just better. Forget about the medieval dinosaur of XML. But what is it exactly?
Because of the browser, JSON is a JavaScript object notation, and the browser can take the format and parse it to an object.
Yeah, I mean, yeah, you're right. I mean, its essential purpose is to encode JavaScript objects, right? So it's really centered around the tech there, right? Is it impossible to parse XML formats with browsers? No, it's not. It's equally possible. Damn, back to square one. No, but your argument is good. Both of your arguments are good. One was efficiency, we went to that, and the other one was the fact that it's centered around the JavaScript objects that are essential for web-based applications.
It's also smaller because there's less redundant information,
Yep.
like the tags.
Yeah, cool.
And you don't have to write an opening tag and an ending tag, you just need brackets.
Yeah, exactly. You have the opening and closing braces and so on. Yeah, you have a comment. Not anymore? Any other views, thoughts? Who has played with XML before, just for fun of it? For what purpose, if I may ask? Because you have experience, that's good.
I did it for an assignment.
For an assignment, yeah, but in which course, kind of? Which course?
Database.
In databases, okay, yeah, cool. So you most likely talked about XML databases there, was it?
Yeah.
Right. Which database did you use? Which engine? Anyone? Was it all in the context of the database course for you guys? The ones that just raised their hand?
Data models.
We also used it for data transmission.
Ah,
Yeah.
what's the tool you use for that purpose?
No, it's just for ourselves.
Okay. Right.
It was a really small project.
Okay. Yeah. You, I saw you raising your hand.
That's a database course.
Database course as well. So which database engine do you use for this one, if you recall? Or is it just handwriting the structure?
Oxygen.
Then, okay. Locally?
The only, like, it was just something locally we have to learn in the assignment. If you know what database, you know type of database, we use like the PHP thing.
I see. Yeah, because there was a, yeah?
I was thinking, I think I remember we were using a kind of searching algorithm kind of program to parse or to search in the XML values.
Yeah, okay. So, yeah, so that's interesting. But you see already now, just by discussing it, where those formats can be found, right? So we talked about transmission before, Jason, right? So all those guys talked about XML in the context of databases, right? So, and that's probably not necessarily central to transmission, or at least not only, but they have other purposes or other requirements, please.
XML has it's easier to add additional attributes to something.
Yeah.
Since I don't think JSON remembers much more than or something like that.
Yeah. Yeah, that's a good point. So you have multiple ways of adding data or information, right? Which can, of course, increase the complexity high. But on the other hand, also gives you that flexibility, right? So, you know, the tags that we have, or attributes they're called. Yep. So, but I think that's the major differentiation that we probably want to end up with. That is for slightly different purposes, and that's why you see them in different courses. But I still feel we should go into both and compare them, and then also look at the aspect of performance, which is also a notable concern. Not so much to say distinctively what's better, what's not, but to leave you with a slightly different message. We go about this. Is there any other format you guys are aware about?
Comma separated values.
Sure. Yeah. Okay. I forgo those. Yes. But they that's right. They can be highly efficient, right? So in terms of transmission, yeah. But they make certain assumptions about the data format, right? About a very structured data format.
You
So
really need to know how it's set up.
exactly, right? So and then you can cleverly omit the headers, and then you're very efficient in terms of you have pretty much payload only transmission. Okay. Well, let's go for that. So. Okay, so let's talk about a few formats to just give share an overview and also a comparable overview. I think that's quite important. And one is, of course, XML. I'm introducing those formats roughly in a chronological order. That is, you know, the kind of time frames they came about, or at least popularized, more or less. So, Jason, of course, YAML. Did anyone hear about YAML before? Yeah? When did you use it?
Docker?
Ah, there you go. Good. Someone recalls that, so you use it, please.
I've also seen it being used in settings usually.
Yeah. So again, a very good example for application areas. So for configuration files, YAML is quite common. But then we also look at transmission formats. See if we get there. Beason, what is that? Yep.
If I recall correctly, I think it's a byte stream of JSON.
Yeah.
Formatted to be counter.
To format it to be? Sorry, I didn't get that.
To be reduced size.
Yeah, right. So it's really a binary JSON, basically. That's the idea. So it's meant to be. What is the downside of all those formats here, or the upside, or the shared feature of all those top ones? Just to clarify that.
Human readable.
Human readable, right? So really, if you intercept one interaction of you know, XML request response and so on, you can read request and response, right? So human readable. Problem with human readability.
Security.
Number one. Number two.
You have to format it in a certain way so that you can read it.
Yeah, exactly.
Not optimized for computer.
Exactly, right? So we have this trade-off. Do we optimize for humans or do we optimize for machines? I mean, if you optimize for humans, it's by definition not optimized for machines, and conversely, right? So we're not really good in reading binary data streams and so on, but we're really good at reading, character sets and alphabets and that we're used to, right? And if we have the syntactic differentiation that you're describing, so we need to have all those features that make it readable, formatting, blah, blah, blah. All that. So they all have this feature, and this one gets rid of this and kind of tries to link the benefits, specifically of this one, with the efficiency of machine readability, right? So that's that one. Beeson, was that protobuf? Anyone? Do you hear about? Do you use it? Do you have to use it? Sometimes more on the have side than actually use it. No? Oh, good. Good. We'll talk about this as well a bit. Cool. I mean, those will roughly cover our be enough to cover some ground today and leave you with some impressions about the different formats. The part of the reason is, on the one hand, to give you a bit more of an informed a basis to make informed decisions when to use what or not, or to understand why people use what, right? So sometimes feel, hang on, you're really using XML in the in the year 2020, and then looking at the data more concretely, you may actually realize that it's probably not the worst choice, right? Or the opposite. And the same there. If you are asked to develop something that's reasonably efficient with respect to transmission, well, it probably makes sense to look at those ones, right? So consider those as one of your as your approaches for data transmission. Please.
Are servers like a database like MySQL? Does it use one of these formats to transfer?
So MySQL specifically has an own format, so it is proprietary MySQL. If you use that. But other database, I'm not sure if there's some sort of an extension for MySQL that could possibly do it, but I know for other databases they can usually return in such formats. Typically it's XML. Because in the early 2000s there was a bit of a move, because XML was a big thing there, because it could do, and that's why using in databases, it can do nearly anything you can do it can represent relational schema more or less completely. And the idea was that, hey, let's get rid of all those proprietary formats inside database management engines and just supplant them with XML. So we have, first of all, interoperability, you have readability, we can debug them, if things crash, we still read the data, and so on. And it's very natural, at that time that was the thinking, and very easy for humans to interact with XML, right? So writing queries could be a lot easier, especially for ones that are not acquainted with SQL, for example, right? So on those grounds, but it turned out it's in the end there were some approaches to do it. I don't think they were particularly successful. What happened more or less was that the existing engines, so Microsoft SQL, Oracle, and so on, they all extended their existing interfaces with an option to return data in those formats. But for a true or pure XML database, I don't think there's many, at least not popular, many existing anymore that actually do this consistently. The idea was to use XML for everything, right? So very rigid approach. So you need to look a bit of the feature set. Some databases do. I just don't know whether MySQL/MariaDB does that. I just don't know right now. But it could well, since that's one of the features. We'll get to that in a second. So cool. XML. Do we still use XML somehow today? I mean, you mentioned JSON's a thing to go. Do we use it at all?
We use it a lot as a markup language. Like in Android, we can define layouts.
Aha, right. So why don't we use JSON there? I mean, why are those Android people so notoriously behind and still using XML for? Yeah.
It resembles HTML more, and that's what we're used to when we make layouts.
Okay. One argument. Yeah. Good. Yeah.
I was thinking that XML allows for more attributes to be defined,
Yeah.
and easier to group them.
Yeah. Yeah. So what is another factor that could be relevant?
It's more readable.
Well, now you
just know the tag. You know the tags where they are.
That's correct. Yeah. I know exactly what you mean.
Yeah.
So if you have nested structures, they're much more readable because you see begin and end tags,
Yeah.
right? So
JSON, you have to follow the
Yep.
curly brackets.
Exactly.
See where it begins.
Exactly.
And ends.
So in the end, is it super readable? Depends, right? So
Maybe you have an extension that makes them different color, and then you know where it is. But
sure. I mean, apart from tooling support, I'm thinking more about structure.
yeah, but that's structure maybe not so as XML.
Right. So so the point is there. Yes and no. It depends on the complexity of your structure, right? If it gets sufficiently complex, then XML may be a better approach, but based on the begin and end tags, right? The nesting. But you're into something. Why still? I mean, we have more attributes we can capture. And you said it implicitly, it resembles more like HTML. What does HTML resemble actually?
More XML.
Yeah, but what? Yeah. But what does it fundamentally represent? What's its purpose?
Semantics.
The most is syntax, but what is it used for? Yeah.
I'm thinking defining an object and then listing its attributes.
Okay. But isn't that the purpose of
you have
JSON?
a text or
Yeah.
image,
Yeah.
and then you also say that this has sizes.
Okay,
this and
Right. So you have attributes or meta information that you want to carry along. Absolutely sure. Fundamentally, the idea, yes, you're on the right track, and I think you implicitly captured this already. Well, the key purpose for XML is to represent document structures, right? Websites are documents. Well, at least that's where they're coming from, right? So that was the idea. How do we communicate something that's hopefully human readable, including presentation, blink tags at that time, which are now illegal, luckily, and things. But fundamentally, it originally represents or replaces your telephone book, right? So because that's the origin of the World Wide Web, right? It was about looking up people and see what they actually do, and CERN in particular, right? Has moved on from there, but the essence hasn't changed. It's all still about documents. And the representation of documents in HTML or XML is just perfectly suited, right? Whereas JSON is much more open-ended, right? It's not specific to that purpose. It's actually more geared towards representing objects, generally in the form of maps, right? Key value pairs, right? So that's a much more simpler purpose that is associated with this. But we get into one other big example advantage that comes along with XML, or baggage, depending on your perspective. So this thing is quite an old one, mid-90s. There was a cursor for XML that is known nowadays. But fundamentally, XML came up in the or was specified in the mid to end 90s, and it kind of the idea was really just to describe documents on the internet and also to deal with the ambiguities that HTML had come up with to some extent, because HTML is even more down the road of human readability because it confuses structure and presentation, right? So it has presentation features like, you know, colors, formatting elements, which are technically which are not necessary for machine readable, human readable transmission formats. They're just a waste of space, right? Having BR tags and paragraph tags and divs and all that kind of jazz that is just on top of it. And then it actually became clear, well, you know, we can describe all this in terms of XML. Anyway, we get to that in a bit. But XML is slightly more pure in that it really concentrates on the data. And that, again, makes it clear why it's so heavily used in the context of database for documents, but also for database descriptions. And one of the purposes is, unlike JSON, is that it actually affords a comprehensive description of the structure if you have a document. It doesn't leave anything out. It's really clear about this. How is it done in XML? What's the technique they use to ensure that something is complete?
Use an XML schema.
Exactly, right? Schemas talk about this. Exactly. So that's part of the specification. Right? So the idea is not only to have XML applications, as they're called. Applications are specific formats, but also the idea of schema support. So you can assess whether you're committed to that particular format, right, in that layout. And there are still a wide range of different formats that are still based on XML. So if you're thinking you're not using this dinosaur anymore, you may be mistaken. So there's quite a bit. So as atom feeds, SOAP, what the hell is SOAP? It's in your shower mostly,
Software.
but yeah,
it's like Rust and something like that.
like REST, not Rust, right? Or
Rust, yeah, something like Rust, right?
Rest.
Rust API.
The REST API, not the Rust programming language. It's one simple good.
no,
Okay,
Rust.
yes, that's exactly something like.
But
Okay.
I don't remember how it's the acronym.
Yeah. So, that's a good. Yeah, you're putting something. I actually don't know it right now myself. So it was. It's basically
It's a protocol.
Yeah, it is. It's a web service standard, and that precedes pretty much.
Simple object access protocol.
There you go.
Yeah.
So what is used for?
is messaging protocol specification for exchanging structured information in the implementation of web services.
Yeah, yeah. So it was more centered around web services, but unlike REST, it did not necessarily had a resource-centered view. So you would not communicate changes in terms of resources as they're managed on the server, direct interaction, but rather have more functional interaction, but using XML as a payload schema for the request and responses respectively. So basically encode content in a fixed schema called SOAP, which was based on XML. Or is still. I'm not sure if it's heavily used. SVG, anyone? Did anyone use it? Who's taking the graphics course? Please.
It's an image format so that you can get resources from outside the file, I think.
Cool, yeah, sure. Yeah, sure.
It stands for scalable vector graphics, so it's just
Yep.
an image that we define with vectors.
Yeah, that's right. And you have anything to add? Yeah, did anyone open SVG file before? How? How did you open it? Well, the question is, did you open it in your browser or did you open it in your text editor? Because then you see
Results.
a slightly different output. So because you'll see it's pure XML, this thing, right? So it's basically describing a graphic, usually, of course, not a photo, but schemas, figures, line charts, diagrams, and so on, in terms of vectors that are specified in XML. So the cool part about it, you can actually freely modify this image by modifying the underlying XML, right? So quite neat one. So it's also web standard de facto supported by most browsers, I think. Probably every browser still. Kind of a bit going out of fashion, I think, for a reason. Slightly inefficient, of course, because it's text-based from a transmission point of view, but very nice from a modification point of view. And then, of course, we have all those XML-based formats, including Word, for example. docx is XML-based, right? So you know under the hood, if you unzip this thing, you actually get a fairly complex folder structure and, of course, a lot of XML documents. So it's heavily used. EPUB, which is used for e-readers, MathML, representation of mathematical formula in a standardized human-readable way, right? Because we don't have those symbols, the sum symbol or sigma or whatever else. And if you want to represent this, particularly for complex equation, then there is an XML application for that as well. So just to clarify, there's quite a bit of stuff out there. So first back in 1996, okay, sure. And the current one we're working is from 2006, so also a bit of dinosaur-y kind of feel, right? So yeah, you would have been born, sure, but still barely, right? So it's quite an old specification. Basic principles, just for anyone who has not been exposed to it or has not, I don't know, just to you know, as a, ensure that everyone is still on board. So the idea is basically that you specify a document with start and end tags, right? They differentiate in that they have a slash in the end tag, but fundamentally the idea, and that points to the inefficiency that you highlighted before, fundamentally all the entries are kind of characterized by a fixed keyword, fixed term, right? That is specified either by XML more generally, but probably by your schema more specifically, right? So entry has a certain meaning in the context of your document type you use. Attributes that's an interesting one. You alluded to it. So in addition to those start and end tags, you know, in which you can nest structure and describe. Again, if you're coming from a JSON world right now, we'll see an example in a bit. You know the curly braces, right? So basically, the idea is that things that are inside there, roughly, they would represent the actual content. But in addition to this one, you further have the option to annotate the entry tag with another attribute. So you can provide additional attributes you know, provide second order information. And there can be multiple. So it's really, really nice. You can have actually the core content, the core payload, so the entry value, you know, telephone number, whatever else, right? And then you could have an attribute on top of it, so entry space and then some sort of other identifier equals, and that could be, for example, oh, this is a home telephone number, or a mobile number, or a work or office number, right? Those meta information could be nicely captured without confusing this structure by introducing further nesting, right? So there are two ways of containing information that can relate to each other. That's why people find it sometimes confusing. And say, well, it's too complicated to deal with this, and to pass all kind of that JSON is a lot easier. We know that's where the stuff is, right? We know a fixed structure. We basically have two major data structures that we need to only be dealing with. So we have those features. And of course, then we have XML elements, which are basically a composition of those tags, right? So we can have much more complex structure, nested structures, and so on that we find. So here's an example for classical entry or tag entry. Here's the attribute entry. And then usually on top you find something like an XML declaration that points to the version it's referring to. Again, CAN 1.1. It's best practice to have this in there. Any validator will ask you to put it in if you haven't. But it's of course, you can play around with this. This is a classical XML layout you find in the older version, but just whatever copied it in. So you get a feel, kind of makes sense, right? So we have a document that describes bright stars, and then you have selected instances that are embedded in this. Quite straightforward. There. Fundamental feature is we have a single root element. It's important. You can't just have a collection of items, right? So, or especially unidentified. Unlike in JSON, where it's much easier to do so, but for proper formatting, you need to have a single root element. And this is kind of indicative of document-based formats at all times. They always have a root implement because they represent a tree structure fundamentally, right? So it's not just a map structure, for example. So that's important, document feature. And of course, the thing is here, you always need to have this matching, right? So if you have a tag, entry tag, guess what? You need to have a closing tag as well, an end tag as well, right? So, and that happens for all elements, right? So it's always important in mind to bear in mind that this is one of the features, and this is where the inefficiency comes from, right? So that was mentioned before earlier. Hang on, we need to write everything twice plus a slash on top of it, right? So, but it's kind of readable, but kind of not. I don't know. It depends on how do you see it, right? You may imagine that for rather simple layouts, it's a lot of overhead. It becomes more complex, and you have nested elements in there. If you, for example, have the positioning of particular stars as well, or then it probably becomes much more, or a large number of elements, then it becomes much more helpful to actually have those annotations. Or if you have multiple numeric entries here and you don't know anymore which one was. So that's really a purpose. Good. Right. So yeah, those need to be unique, of course. That's the attributes need to be unique within the different elements. All right. So strong on nesting structures. But it goes further. It actually has an interesting feature, which is internal references. Give me a second. I probably can show you an example. If I find it, hang on. Yeah, let's use this one. So here's a more complex one, just to evolve a bit. So assuming we're modeling that's borrowed from somewhere else, but it's linked in the slide set. But it's actually quite a nice example to highlight some of the key features in terms of anchors and references that you can have in standard XML formats. And if you look at this one, this resembles basically, I'm not sure how readable that is supposed to be, a bookstore, right? So a bookstore consists of what? Well, books and authors, for the sake of simplicity. So you see already it's basically basic database structure, right? Did you see that particular one example before? No? Is anyone acquainted with this? Okay. And the idea is that it has a very simple representation of relational structures already. So it shows the power of being able to capture basically a database schema in or database rather, inside a single file, right? So in JSON, that would be really a pain dealing with this, or thinking about this even. But here it's very explicit. So on top we have books, right? So books have titles, books have authors. Authors is a kind of a nested element, we get to that bit. But books, you see that we're actually making use of the attribute marker, right? So we want to declare the ISBN, additional meta information, because the title is not unique for books, right? You guys are aware of this, please.
Sorry, what is
the sorry?
What is
Oh, line feed. Sorry, I use Snowflake++ and I make the line breaks explicit. So it just means line break. I don't know. Yeah. I could. So that's just yeah. I probably can switch that off. If I knew how to. All right. Okay. There you go. So that's more legible, I guess. Sorry for that. Because sometimes I want to, when I'm writing, I want to pick up on white space at the end, because sometimes they are superfluous and shouldn't be there and so on. So it's just for clean formatting. But here, so in essence, you have a bookstore. A bookstore consists of books. Books have ISBN numbers, but of course they also have titles. They have authors. And the author thing looks quite weird, doesn't it? And that's one of the features that you actually have. Because if you look at the bottom here, in addition to declaring books, it can also declare authors. Here in this particular example, so we have an author ident, then we have some sort of unique, primary key for the particular author, which is embedded as an attribute, and then we, of course, the associated value attached to them. And then you can make reference to this using this anchoring scheme here, right, where you make reference to the author identification and just use this attribute as identifier. So you can have simple representation of those references in there, which is kind of built into the idea. You can describe this relationship in a schema to show much more complex structures. So based on, you can actually normalize your data structures quite neatly, and that's kind of comes for free to some extent. But people rarely do that. They only see the single document layout and are slightly scared away by this, of course, understandably, admittedly. I'll just see if I find the schema. Any comments? Yeah, please.
About the author, if you want to save on character is used for whatever reason, is there like a no to just put all the fields as attributes in the main author tag instead of using? Yeah.
So you're suggesting basically encoding everything as attributes, right?
Well, yeah, because then you would save some characters.
You would save some characters on the redundancy.
Which could be important in web sending it.
I mean, you could force it. You can also specify in the schema. I don't see any. From a pragmatic point of view, I probably would say sure. First of all, but 2 points. One of them is probably not really readable, right? So because it destroys this kind of uniform, can destroy a uniform structure, right? The readability of text, unless you can accommodate the formatting. But according to the second one, it's just a bit more of a kind of semantic parsing perspective, suggesting that you encoding data that sit on slightly different levels, right? So first of all, last name and first name have some sort of, there's some integrity to both of those, right? They're kind of related within the attribute, right? Not in a relational sense, but in a real world sense, right? First and last name. So that's why you want to possibly define them together as a nested element. And the fact that you're storing different types of data suddenly next to it. So first and last name belong together. ISBN doesn't really fit, right? So ISBN relates, well, ISBN is a bad example because it refers to books, not to authors. But if you had, let's say, a unique author ID, it would be a different natural kind, right? So it would be a unique identifier for the author, but it would not be the content of the author description in itself, right? So I think from a modeling point of view, it's a bit odd, but I don't think there's, from a syntactic point of view and specification point of view, you can actually go for that. I don't think there's any reason not to. I would just, people shy away from overusing attributes because it harms readability. That's one of the key objections to those ones. They're usually meant more for annotations, right? So meta information or something like this. That's not core content.
Yeah, I've seen.
But they have uses, of course.
I've seen some XML that uses just wherever it can, it just puts it as attributes.
Yeah.
Instead of putting it between tags.
From an efficiency point of view, you are right. Of course, it reduces massively on load, but it comes at other expenses. So, yeah, sure. I mean, yeah, yeah. So it's probably more aesthetics and rather than any particular other reason. No. So from a specification point of view, we have the flexibility to do that. So. So XML is not only, as you guys implicitly alluded to, XML is not only the XML layout and all that kind of stuff, but actually comes with the idea that there is, so those are the requirements for well-formed XML. But it also comes with usually with a validation tool set, or let alone the standard is open, so it has been adopted by many tools, in fact, to afford a assessment of well-formed XMLs, right? So the idea is then as follows, that you have a specification so that you have the specification of XML more generally. You have an XML document, and you can figure out, is it actually well formed, right? Basically, that's a basic check on those three conditions, basically, right? So single root element, match text, proper nesting, and unique attributes within elements. So that's important. So then you have parsable XML. That's fine. But it's not enough. So that's something that has been explicitly recognized in XML. So this is just a baseline check. That's similar for JSON. You get that for free. We actually have a valid JSON object, of course. And again, since it's mostly centered around document representations, it also should afford complex data structures, nested data structures, and relational aspects to it. We saw it just now. For example, invalid references from author to books, right? So, from books to authors. So if you have a reference from book to author and there's no author apparent identified or related to it, then this is a bit of a problem. And then, of course, provides interoperability challenges. So, for example, if you provide a particular document, and in B2B it's quite heavily used, so business-to-business transactions, so if you perform orders, XML is still quite heavily applied, because it allows that you provide someone else with a specification and the associated schema to say, this is how your document looks like, not only to be valid XML, but to be valid XML order XML for my particular company, right? There are certain standards like Rosetta and so on. So basically you provide those standards and say, this is how an order needs to look like. And that's the idea of the schema that you guys mentioned already before, right? So coming back to the example earlier, this is the relationship you would see. So on the left side is the example, and this particular application of XML is based on this particular schema, and the schema is described as follows. There was an earlier approach to describing schemas using so-called template documents, ETDs, but this has been abandoned a long time, so the proper way of doing it is to have so-called XSD, that's the extension usually that describes an XML schema. And it says basically what's the schema based on, sure. And then the element structure, right? So we have an element that is branched down on top level, and it contains a complex type. So anything that's generally consists in more than one element is considered a complex type. And then within this complex type, we can say, well, they come in a sequence, right? It even ensures the order of those elements in the validation process. And there's one called name. It is of the following data type. So there's some typing in XML. I think it's a bit more on the weak side. I mean, you have differentiation between string, decimal, so decimal place representations, and integer representations, for example. And then, of course, the closing element for this particular sequence, the complex type, the element in the schema. So that's in the simplest form a schema you would possibly see that describes it. And what this one allows you to do is basically to validate. Just to complement this from the book point of view, bookstore point of view, it becomes a bit more complex here. So to some extent, the schema of just describing the relationships is longer than the actual document that we have just seen as an example, of course. But the idea is, for example, that the bookstore consists of complex types of books and authors. They won't follow when I, yes, no. And you have also the ability to provide cardinalities. That's really nice, right? So you know this from your relational database structures. I can you specify this. So minimum occurrence and maximum occurrence is then captured as well. So you can actually model this quite nicely. As one. Then you have book keys that it includes the choice of the book and the associated here a field, which the attribute is the ISBN number, for example. Then we have author keys. They look like having an author and an identifier associated with this. And that's how references look like. Author key reference refer to author keys. And they make reference to the author identifier. So let's see how I resolve this here. Book. Where's the author's? See it right now. And there's the field author ident. Here, that's the author identity. Hang on. Probably to scroll down further. So it becomes quite messy quickly. So that's the author key, refers to author key, and looks at the author auth field selector, which is right, down here. Here's the author field. Right, okay. And the author, so if you look at the book type, so we have a book that has a type as a string, has multiple authors, makes reference to the author, and uses the author identifier. It's also a string, and here, for example, talking about cardinality, for example, or optionality, this is required, so, and so on. So you can basically specify this. There are a lot of editors for doing this. One, for example, XML Spy, that allows you to either infer the structure or to specify it in advance. But you see, you can get quite far. By just having the schema, you pretty much can comprehensively describe our previous document. So quite neat stuff. A lot of tool support available. But you see, it kind of sits more on the high end of the challenge level, right? So from a validation point of view, it then just that's the idea of having valid XML in addition to well-formed XML. It's the difference between those. So well-formed is just, does it comply to the basic layout of an XML structure? And valid XML, does it comply to schemata as they're provided? And when you evaluate it against a particular schema as part of using the XML parser, it will actually just tell you whether it doesn't satisfy the validity aspects of it, right? So is the bookstore valid, for example, right? Does it does a book, for example, have a title and an author? If it doesn't, it will not pass the validation stage, but it will pass the well-formedness, right? Because it's still valid XML, but it's not compliant with the particular schema. So anyway, I don't want to drill it too deep, so here's more extended subset. So what is possible to represent is really you have IDs, so it's pretty much like unique identifiers, or then ID references. So think foreign keys, right? So it's quite neatly nested in there, represented in there. We have typing, we have nesting of structures, so the complex structure you can do. We can assume ordering, right? Which order things appear in a sequence, for example, and cardinalities as well, right? So it's quite neat in terms of all the features you probably are acquainted with. Just to give a rundown. So you probably see already, looking at JSON and looking at XML is a bit like apples and pears. It's not the same thing, right? You can't just, that's why I want to put some emphasis on, really. All right, shifting from that one, I think, you probably deserve a break, right, from me? Yes, you do. 10 minutes? Or is 2 enough? Evidently not. So, okay, 10 then. Okay, 11:10. Yes, continue. Because then I turn to Jason briefly.